Hi, I'm Nitya Dhanushkodi, and I'm an engineer on the app connectivity team at VMware.
Hi, and I'm Tim Downey, also an engineer on the app connectivity team at VMware.
Today we're going to talk to you about bringing the CF maproute experience to Kubernetes. First, we wanted to tell you a story about how ingress routing looks in Kubernetes today. You've got a developer, and they want to set up a route to their application. So they figure they'll go configure some DNS and point it to a load balancer. And hey, they realize Kubernetes has got some tooling for this. So they learned they can deploy an ingress controller and some Kubernetes ingress objects to set up the route host. And in order to have encrypted traffic from clients to their ingress router, they've got to add some Kubernetes secrets. And now they need to configure the route to reach an actual backend. So they need to figure out which type of service to use and set up the service to select their app pods. And if they deploy multiple apps that need to talk to each other, they'll want to add network policy, especially if this is a multi-tenant cluster. So that's a lot of pieces. And the same process needs to happen for other apps deployed to the cluster. So you can see the flexibility and power of Kubernetes, but also the difficulty managing all the YAML and decision-making that comes with it. So that's why we've been working on bringing CF maproute to Kubernetes. We want to dive into some of the key decisions that we've made in bringing this to the platform and what implications they have. So first, let's take a look at how CF maproute works on CF for Kubernetes. I'll show you all of the components and pieces involved in making maproute work, and Tim will dive a little deeper into them later on. So in this window, I'm targeting a CF for Kubernetes environment, and we've got my app deployed here. So my app exists, and right now it doesn't have a route, so let's go ahead and add one. Great, so now we've got a route here. And when we mapped the route, RouteController created a route custom resource, or a CR. So let's take a look at that. Cool. So the route CR here looks a lot like the RouteController representation of a route. It's got a route GUID here and a list of destinations that it's mapped to here. And in this case here, it's my app. And let's make sure that my app's GUID matches this one. Cool, so they're the same. And this route CR is used by a component that we've created called RouteController that looks at changes to route CRs and creates Istio virtual service CRs and Kubernetes services. So if we take a look at RouteController, we can see that RouteController is just a deployment in the CF system namespace. And let's also take a look at the Istio virtual service that was created by RouteController that corresponds to the route we just saw. Cool, so this is the virtual service, and you can see the owner reference to the route here. You can see the host and also the destination. And this destination actually maps to a service name. So we'll take a look at that service. It's actually created by RouteController as well. And it selects the app pods that we're trying to route to. So again, in this service, you see the owner reference, which is the route we've been talking about. And the selector selects the my app pods. You can see the GUID again matches. So in order to make ingress routing work, a virtual service ties a route FQDN to a backing service which selects the app pods. In the demo, I mentioned using an Istio virtual service. So I want to step back and discuss what is Istio and why are we using it. Istio is a service mesh that enables us to take a lot of the logic related to networking out of the application and put it into the service mesh. This is achieved in Istio by configuring a series of Envoy proxies deployed to the platform. These Envoy proxies are deployed both as sidecars to applications. You can see one on every app pod here, and as a router into the cluster. You can say the Ingress Gateway Envoy here. And Istio acts as the control plane for these Envoy proxies by configuring them. To zoom into the Ingress routing case, we have an Envoy proxy deployed as the Ingress Gateway, and the Istio custom resources are used to configure the Ingress Gateway to route to a backing service. This diagram illustrates the Istio config involved in our maproute example. So Istio has a set of controllers that act on this virtual service CR, this gateway CR, and other Istio custom resources to configure the set of Envoy proxies as desired. So why Istio? It has a lot of features that address common concerns of developers and operators. Envoy proxies have a small footprint and can support a lot of these common concerns. So Istio can configure them to do things like add MTLS everywhere, emit rich metrics, and shift traffic to new versions. So while Istio has all these capabilities, it can be hard to manage and configure. So bringing the power of Istio to the platform while giving people the CF experience by ironing out the rough edges and making it easier to configure is something we're really excited about. So now Tim is going to dive deeper into the Route Custom resource.
Hi everyone, it's me, Tim again. And I'm here to dig a little bit deeper into the RouteCRD and RouteController and how all this stuff works behind the scenes. But before we begin with that, I want to take a second to level set and lay down some vocabulary. So you've heard us talk about CRDs and CRs and custom resources a lot in this talk, and I'm going to keep talking about it. But I want to just make sure we're all on the same page with what that actually means. If you already know all this stuff, that's great. But if you don't, just know that a CRD is a way of defining a custom resource on the Kubernetes API. So like Kubernetes supports a set of resources already, things like pods, services, deployments, all of that stuff. CRDs just lets us add our own idea of what a new resource could be, in this case, a route. And it will behave pretty much just like those built-in resources. And the cool thing about this is CRDs are automatically supported by clients of the Kubernetes API. So that's how Nitya was able to just kubectl get routes, and it worked just like anything else. And lastly, but maybe most important for us, we found that CRDs provide a good boundary where it allows components to coordinate through the Kubernetes API instead of talking to each other directly. So with that out of the way, let's look a little bit closer at the RouteCRD. The RouteCRD is just a declarative representation of a Cloud Foundry route. Like Nitya showed, if you're familiar with what a V3 route looks like in Cloud Foundry, this is pretty much the same thing. It's just YAML instead of JSON. But it's some premium YAML. And it enables components running on the Kubernetes cluster to discover information about how an app should be routed to without having to call out to Cloud Controller. They can just talk to the Kubernetes API like they're used to. Today in Cloud Foundry, the Cloud Controller API is the source of truth for pretty much all desired state in the platform. It makes sense then that Cloud Controller is the source of truth for these route CRs that exist in the Kubernetes at CD. So anytime a developer types CF create route, CF map route, delete route, Cloud Controller is going to call out to Kubernetes and update those route CRs. But as Nitya showed, a route on its own is not enough to make something routable. There are also services and virtual services involved there. But where do these come from? It's definitely not the Cloud Controller. Instead, it's that route controller that she showed. And it fulfills the role of a Kubernetes controller, something that continuously watches for updates to a particular resource, in this case a route, and performs reconciliation on it, and what is known as a reconciliation loop or control loop or what have you. Anytime someone updates a route, creates a route, deletes a route, RouteController is notified, and it will take the appropriate actions on updating the Kubernetes services and virtual services that correspond with that route. So let's just look a little bit closer at how a route maps to these resources, starting with a service. So here we have a route with two destinations. That means when you hit multiapp.app.example.com, this is going to be directed to app A, we'll call it an app B. The route controller will see that this route was created and then in turn make two services that correspond with it. The coolest thing about this to me actually is note that the selector for these is pretty much the same. RouteController just transparently copies over the selector that was defined on the route itself without having to know how this route actually maps to anything. So today, Cloud Controller considers a route mapping to be mapping between a route and an app based on its GUID and process type. But imagine if that changes in the future. Maybe Cloud Controller wants to implement finer grained routing and introduce routing by process GUID instead, in case you have multiple web processes for an app. Well, all they have to do is update the selector on the existing routes, and our controller will see that those resources were updated. Then just go ahead and make the change on the services. It all will just happen without any coordination between our teams. So similarly, we create virtual services to let these things actually be externally routable. So here we have two routes, pretty much the same, except for the second route is doing what we call context path routing, where it's routing all traffic to the /admin path to a separate app. We aggregate all routes for a given fully qualified domain name, or FQDN, into a single virtual service, which handles the matching based on path prefix, as well as any weights that were specified on the route. And similar to the services, anytime destinations are updated on a route, virtual service is going to be updated as well. So that's cool and all. But apart from some shiny new components like Istio and Envoy, and the fact that everything's YAML now instead of JSON, how is this any better than what we have in CF for VMs today? And that's a fair question, honestly, because right now we're pretty much focused on reaching feature parity with what the Go router and existing container-to-container networking solutions support. But what really excites me is what this can enable for the future. And I just want to disclaim here that the following slides are purely hypothetical. This is all stuff like kind of pie in the sky of what will be possible potentially. So just read the title here. Swappable Ingress / service mesh. Like Istio, like Nitya mentioned earlier, Istio is it's really powerful. It gives us a lot out of the box, and it's allowed us to move fast because we don't have to implement those things ourselves. But to achieve that power, Istio ends up being pretty heavyweight, and it's got a large footprint. So for some users, maybe all these features are overkill. Maybe it's just a small dev team and they don't need weighted routing or something. Or maybe some operators out there are just like used to running other ingress controllers or service meshes like Linkerd, and Istio is like not something they want to learn. Well, traditionally Cloud Foundry has been pretty much like a one-size-fits-all platform as a service, with a focus, for better or for worse, on large enterprise development teams. But Cloud Foundry for Kubernetes, it's not a baseball cap. It doesn't need to be one size fits all. And thanks to the RouteCRD, the ingress and service mesh part of that definitely doesn't need to. The RouteCRD helps keep Istio as an implementation detail. Users running CF map route aren't exposed to its complexity. And this also makes it so that we could swap it out potentially in the future. So here's an architecture diagram that's pretty similar to what we saw earlier, with one major difference. Instead of creating Istio virtual services, RouteController is creating ingress controller resources and Linkerd config. That's it. Everything else on here is the same. Notice that the lines coming out from Cloud Controller haven't changed at all. And this is because at the end of the day, everything is just talking to the Kubernetes API. It's mediating the interactions between Cloud Controller and Route Controller. And Route Controller, because it's just writing out Kubernetes resources, very little of it has to change. So that's it. We've seen the reconciliation loop and how Route Controller is converting routes into virtual services and Kubernetes services. And we've seen some of the possibilities that the future might hold for these components. But I just want to say one more thing. As a contributor to Cloud Foundry on Kubernetes and a previous contributor to Cloud Foundry on Bosch, I just want to reiterate that I found Cloud Foundry for Kubernetes just so much more approachable. I no longer have to worry about writing Bosch releases or managing a Bosch director and an environment just to try out some small changes I might want to make to a component. With CF for Kubernetes, you just got to change the code, build a new Docker image for the component, kubectl apply, and your changes are out there in minutes. It's a really fast feedback loop, and I think it's a lot more approachable for folks in the community who might want to get involved. So if you've seen anything today that sparked any ideas, like maybe you want to try working on Route Controller and swapping out Istio for something else, or maybe you want to just like bypass Cloud Controller and kubectl apply. I don't know. I'd encourage you all to experiment and dream big and just try hacking something together. Well, that's about it. Thanks for tuning in, everyone. If you'd like to keep in touch with what we're working on, feel free to hit us up in Cloud Foundry Slack in the networking channel, or hop on over to GitHub and you can follow along with our progress in the CFK's networking repo. Now we're available for some live Q&A, so see you there.